In this video, we're going to talk about function notation. Function notation is a concept that's actually not as difficult as it sounds. Notation is just how we write things. So because we're talking about functions which have inputs and outputs, basically, instead of saying y equals something, we're going to be using f of x or g of x. So that's what is meant by function notation. If you take a look at your screen, it says evaluate f of x equals x squared plus 3x minus 4. First of all, when you see the f with the parentheses x, you read this as f of x, okay? And the function could be g of x, h of x, and it doesn't have to be of x. The inputs can be any letter. It could be f of p, or sometimes you're talking about height in terms of time, so it's h of t. So that's basically what's meant by function notation. All we're going to be doing in these exercises is substituting. So if you were to be given a problem where they gave you an equation and they told you to substitute, you would know exactly how to do that. Well, this is exactly the same concept, except that it looks a little bit different. So for part A, it says evaluate f of 2. So in part A, when we have to find f of 2, that means that you're going to take the equation they give you, and every time you see an x, you're going to substitute a 2 in its place, and then you're going to go ahead and simplify this. So 2 squared is 4, 3 times 2 is 6, so then 4 plus 6 is 10, and 10 minus 4 is 6. This means that f of 2 is equal to 6. Let's go ahead and try part B. In part B, they want us to substitute a. So if we go to find f of a, it's okay. We're going to do exactly the same thing. We are going to substitute an a wherever you see an x. So I'm going to write down a squared plus 3a minus 4. Notice that none of these are like terms. Unlike the previous example in part A, there was an actual number that we substituted and we were able to combine. Here, because a squared, 3a, and negative 4 are not like terms, this is going to be your final answer. So f of a is equal to a squared plus 3a minus 4. In part C, we are asked to find f of a plus h. So I'm going to go ahead and I'm going to write that this is equal to a plus h squared plus 3 times a plus h minus 4. And once again, all we are doing is replacing every single x value that is in that equation with a plus h. So if you notice, instead of x squared, it's a plus h squared. Instead of plus 3x, it's plus 3 times a plus h. So this process of substituting is how you're going to simplify these equations that are written in function notation. Now, in order for us to simplify, I have to find out what is a plus h squared. And that means a plus h times a plus h plus 3a plus 3h because I distributed, and then minus 4. Be careful not to distribute that 3 to the minus 4 because the parentheses ends right here after the h. So I'm going to go ahead and distribute. I get a squared. A times h is ah. H times a is ha, but I want to keep them in ABC order. So I'm going to write ah plus h squared. And then I'm just going to bring down exactly what I had already written because none of those are like terms. So here I do have some like terms. AH and AH are like terms. So I end up with a squared plus 2AH plus h squared plus 3a plus 3h minus 4. So it's very long, but there are no like terms here. Even though I have an a squared, there are no other a squareds. Be careful with the 3a, 3h, h squared, 2ah. They are all different. They are not like terms. And so that's my final answer. So now in part D, they want us to evaluate f of a plus h minus f of a over h. I'm not going to end up doing this again because remember that we already have some of these parts done for us. So f of a plus h, which is the first part that they want us to find, we already found that in part C. So I'm going to copy down exactly what that answer is. It's a squared plus 2ah plus h squared plus 3a plus 3h minus 4. Then it says that it wants me to subtract fa. So f of a is right here. We found this previously in part B. Because of the minus, I'm going to have to change all of the signs for f of a. So that means minus f of a, which means minus a squared plus 3a minus 4, which is negative a squared, negative 3a, and positive 4 if you distribute that minus. So I'm going to go ahead and I'm going to write those down where I wrote down part D in blue. And I'm going to see if I can match them up. So for example, I have minus a squared here. So I wrote it down below the a squared. Then I have negative 3a. I'm going to write it below the 3a. And then plus 4, I'm going to write it below the negative 4 just because I know that they're going to be like terms. Now, all of this is going to be all over h because in the problem, it says all over h. So I'm going to go ahead and I'm going to simplify. The a squares cancel, the 3a's cancel, the negative 4 and positive 4 cancel. I'm left with 2ah plus h squared plus 3h all over h. Notice how they all have an h in common. So I'm going to cross out the h and I'm left with a final answer of 2a plus h plus 3. So the final answer for part D is 2a plus h plus 3. Let's go ahead and take a look at this example. It says, given the function h of p equals p squared plus 2p, evaluate h of 4. Again, h of 4 means that my input is going to be 4. So I'm going to go to the equation and wherever I'm going to see a p, I'm going to substitute the p with 4. So that means that h of 4 is equal to 4 squared plus 2 times 4, which is 16 plus 8, which is 24. And that's my final answer. Go ahead and pause the video, see if you can find g of 5 in the next example, and then press play. G of 5 means that you're going to come to the radical, and wherever you see an m, you're going to replace it with the number 5. Here, the square root of 5 minus 4 is the same thing as saying the square root of 1. And the square root of 1, of course, is 1. So g of 5 is equal to 1. Now, things change a little bit in this example. It says h of p equals p squared plus 2p. Solve for h of p equals 3. When they tell you h of p equals 3, now this is the output. It's like if they were to have given me the y value. So now that's the answer. That is h of p. So I'm going to take the p squared plus 2p, and now I'm going to replace h of p altogether because h of p is equal to 3. So now what I have in my screen is 3 equals p squared plus 2p. I can tell that this is a quadratic, and I'm going to try to solve this by factoring if possible. So 0 equals p squared plus 2p minus 3. We're looking for something that multiplies to give me negative 3, that's going to add to give me positive 2, and that's going to be positive 3 times a negative 1. If you multiply it, you get negative 3, and then if you add it, it's going to give you positive 2. So 0 is equal to p plus 3 times p minus 1, and that basically tells me by the zero product property that either p plus 3 has to equal 0 or p minus 1 has to equal 0. So if I subtract 3, I get p is equal to negative 3. And if I add 1, I get p is equal to 1. So those are my two possible answers for this problem. Again, go ahead and pause this video to see if you can do this one by yourself. Given the function g of m equals the square root of n minus 4, solve g of m equals 2. G of m equals 2. Once again, they're giving me the actual output. So g of m right here is equal to 2. So 2 is equal to the square root of m minus 4. How do I solve something like this? To get rid of the radical, I'm going to square both sides. I get 4 is equal to the square root and the square cancel, m minus 4. So if I add 4 to both sides, then I get m is equal to 8. Express the relationship 2n plus 6p equals 12 as a function p equals f of n if possible. So by them telling me as a function p equals f of n, that's indication that I have to solve for p. I have to go ahead and get the p by itself. 2n plus 6p is equal to 12. If I want to get the p by itself, I'm going to subtract 2n from both sides. I get 6p is equal to negative 2n plus 12. I have to get the p completely by itself, so I divide everything by 6. I get p equals negative 1/3 n plus 2. And because they want me to write this as a function in terms of n, then I'm going to replace the p with f of n. So that means f of n equals negative n over 3 plus 2. And it doesn't matter. You could have kept it as negative 1/3 n plus 2. These two answers are exactly the same. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.